Welcome you all for another an excellent presentation on random variables and random processes. In the last presentation, we have seen the basic definition of a random variable and the properties of a random variable, and then we have seen the corresponding distribution functions of any given random variable. So basically, for any given random variable, we have two types of functions, namely, one is probability distribution function and the second one is probability density function, right? I think in the last presentation, we have covered the definition of a distribution function and we have seen its properties also, right? In today's presentation, I would like to explain you the next function, that is probability density function, and we will see its properties and we will solve some examples, right? We will go into the class now. We will see about the density function now. Yeah, so I welcome for this presentation, and we will see about the probability density function of any given random variable. So how we can define a probability density function? So let us consider, so let us see the definition actually first. The definition of this, PDF. What is probability density function? Right? It is very easy actually. If you consider any random variable x, as I have already told you that any random variable can be denoted by the capital letters x or y or otherwise z or any letter, but you must represent with a capital case letters only for denoting the random variable, right? Therefore, for any given random variable, consider either x or y or z, right? The corresponding its probability density function, that is denoted by small pdf. Always remember small pdf, that is probability density function, and further it is denoted by small f of x, right? This is the mathematical representation of a probability density function, right? How it can be defined for a given random variable x, right? I think it is derived from the definition of a probability distribution function. So in our last presentation, that is in lecture number 2, if you remember that, we have seen there the definition of a probability distribution function there. Probability distribution function, that is what capital PDF. Don't confuse. We use two terms actually. One is capital PDF and second one is small PDFs, right? The capital PDF is used for distribution function, that is capital F of x actually. So this capital PDF is used probability distribution function, or also called as CDF, capital CDF, that is cumulative distribution function. These are the two different names for the single function, that is probability distribution function, right? That is capital F suffix capital X of x. This is called a distribution function. Okay, we have seen in our last presentation a very detailed information we have seen. You can please refer our previous presentation regarding the distribution function. Whereas if you know the distribution function, then from this we can easily define the density function. We can easily define the density function from the distribution function. How? So I will tell you the definition. So it is simply the derivative of means that it is simply means the density function small f of x is equal to, what is small f of x? It is your PDF. This is what your small PDF, that is probability density function, and that is equal to small fx of x. Okay, nothing but d by dx of capital F x of x. That's it. That's it. That is the definition of a probability density function, right? Small PDF, okay, is equal to probability density function is equal to small f of capital X, means it is the PDF of random variable x, or you can represent either y also or z also. If you want to mention capital Y, then you must write here small y, its corresponding possible outcome values. If you want to represent with capital Z, then in bracket you write small z, right? So don't worry, most of the time you will be asked x only. We use the notation x only, right? This is with respect to a single random variable x. Okay, after completion of this presentation or in the next subsequent presentations, we will see about the multi random variables. Multi is nothing but the concept of two random variables. Okay, it is there we consider the random variable x as well as the random variable y, right? So if two random variables are associated in defining the function, then how their distribution and how their density function looks like, that we will see in the next our subsequent presentations, right? So here this is the density function with respect to a single random variable capital X, that is nothing but it is the derivative of distribution function. Means that if you know the distribution and if you take the derivative of it, then whatever the value comes, that is nothing but your density function. Very simple definition. So derivative of distribution, nothing but your density function, right? So this is the basic definition of a density function actually. Right, now just I will explain you about the properties. Actually, what are the properties of this small PDF? I think you are understanding this, you are following it. I will explain you what are the properties, right? Properties of small f x of x, that is nothing but your small PDF probability density function. Wherever small f comes in a problem, remember that it is a density function, not a distribution function. Okay, never confuse, right? Then the first property, the very first property is that, okay, the PDF of any random variable, means the PDF of any random variable, I can write simply RV for random variable. So the PDF of any random variable x or given x is, that is f of x of x, it must be greater than or equal to 0. This is the first property. If you see the density function, means probability density function, small f of x in bracket small x, that should be greater than or equal to 0. This is the very important property and very first property. This indicates that your density function is a non-negative function. This indicates that it is a non-negative. It is a non-negative function. Remember that. It is a non-negative function. Means the value of fx of x should not be negative. It always must be positive, either 0 or otherwise greater than 0. Right? So therefore it is called a non-negative function. This is one of the important property of a distribution function. F of x is greater than 0, and this is the first property. Coming to what is the next property? What is the second property? Let us see. This is another very important property actually, property number 2. So this is nothing but the area under the PDF, that is minus infinite to plus infinite, your f of x into dx equal to it is 1. That is another beautiful property of a density function, right? If you take the integration of your density function, f of x is a density function actually. If you take the integration of this density function over the interval minus infinite to plus infinite, then the value must equal to 1. Its value, the integral of this density function must be equal to 1. That is the another important property. That is the another important property of this density function. Normally, this property can be used. This property can be used while determining the given density function is a valid density function or not. Sometimes in your examinations, maybe in GATE examination or UPSC IES examination or in your regular academic examinations even, so they will give you certain density function of random variable and they will ask you that to find out whether is it a valid density function or not. So for that case, you just evaluate the given density function over the given time intervals or the intervals of that limitations, and you must evaluate that, see that whether your answer is 1 or not. If you get the answer 1, definitely you can say the given density function is a valid density function. Or if you do not get the answer 1, then definitely it does not. It is not a valid density function. Right? So in order to solve that density function, okay, then we will use this property. Very, very important property this is. This is the second property actually. Now, what is the third property? What is the third property? So third property says like this. Say for example, if the probability is given, the third property is that if the probability is given between some x1 is less than or equal to capital X is less than or equal to small x2, let us say, because for a single random variable x is the random variable where x1 and x2 are my possible outcome values of x. Clear? Here x1 and x2 are the possible outcome values. Maybe this is the first value, this is the second value, means possible outcome values, means this is the output of in the first iteration of that experiment, this is the second output or second output of the second iteration of that experiment, of the same experiment. So that is what the meaning of it. So if the probability is given like this, this is nothing but an event. As I already told you in the very beginning presentation, if without a probability, if you write something in the bracket like this bracket, then this is called an event. And for this particular event, if you take the probability, now this is nothing but your distribution function, can also a density function even. So this can be written as, if you okay, this can be probability of this much is nothing but, it is nothing but integral over, it is x1 to x2 your f of x into dx. That's it. That is the meaning of it. Right? So sometimes they will give you this, means, or sometimes what they will give in the problem, you know, the density function will be given. The density function f of x will be given to you. The function will be given over the interval, certain interval they will give, and they will ask you that find out the probability between some 1 less than or equal to x is less than or equal to some 3. Like that they will ask in terms of probability. If they ask like that, what you need to do, you know, so you have to take this integral part, means, so this lower limit to upper limit, you substituting these limitations in the given integral and the given density function you substitute here and evaluate, get some value. That is the value of this probability, right? So likewise, so this is another beautiful property of a density function basically, right? So these are the very commonly used density functions basically, right? So I think These are the very important properties, mostly widely used properties, and the remaining we can see during in the subsequent presentations even, right? So these are the very important properties of a density function. So I think now let me explain you one beautiful example on whether the given density function is a valid density function or not, that we will see. So that you can understand very better. Now write this example. So the example is that is the function I mean probability density function is the function, what is the question, it is f of x. So it is f of x is equal to, it is 1 by 18. 1 by 18 times actually 3 plus 2x. It is given 1 by 18, 3 plus 2x for 2 is less than or equal to x is less than or equal to 4. That is what my limitations, 2 to 4 actually, and it is equal to 0 for x is greater than 4. X is greater than 4, right? So, and even it is 0 again for x is less than 2. X is less than 2. This is the function given. So, is the function valid density function or not? Valid density function. Is it valid density function or not? That we have to find out. Clear? I think you understood the problem. So here function is given f of x equal to this much, and here actually f of x equal to, you can write like this if you need. You can put in a bracket. Like this you can write, right? So f of x equal to, actually it is 0 for x is less than 2, means so below the value of 2 the f of x value is 0, the density function is 0. Then between 2 to 4 the density function is defined like this, and for greater than 4 again the density function is 0. Therefore for these two intervals we don't need to bother actually for 0 values, means you have to consider this limitation only. For this limitation the density function is defined like this. Now what to do, whether is it valid or not, is it valid density function or not? For that simply the very important condition is that because the density function is derived from the distribution function. Remember that the density function is derived from the distribution function, right? So you can say that in theoretical, if the given distribution function is a valid distribution function, then its density function is also a valid density function. Likewise, you need to judge or you need to comment, is it not? So once if the given distribution function is a valid distribution, then definitely its density function is also valid density function. That is the simple thing, right? Now for this given problem, so what we need to do? So you simply evaluate the integral as I told you in the from the second property of the density function. What is the second property? It is nothing but simply integral over, it is minus infinity to plus infinity f of x into dx, right? So what is the integral values? 2 to 4. The limitation is 2 to 4. Therefore what we need to do, what is the thing? I will write the solution for this problem. Just I will give you the integral, then you try on your own. So so the solution part. So to determine whether the given density function is valid or not, simply you need to calculate from the second property. What is second property? Minus infinity to plus infinity f of x into dx. You just evaluate the integral, that's it. see that the value should get 1. You must get your value is 1. So now what are the limitations actually? This is in general. What are the limitations? It is 2 to 4. Clear? 2 to 4. Then what is your function? It is 1 by 18. It is 1 by 18. In bracket, what is there actually? 3 plus 2x. Clear? Of dx. Is it not? Now evaluate that integral. What you will get actually? If you evaluate this part, if you evaluate this, what is the second step? Tell me. What you will get? This is equal to, this implies, right? So 1 by 18 is definitely constant. Take outside here. Then put a bracket there. And then 3 plus dx. Clear? Or otherwise, it is 3 plus 2x. Right? Integral over 2 to 4. Normally, the integral value into dx. This is what your integral, no? And this is equal to, it is 1 by 18. You can separate, means 2 to 4, 3 dx. You can write like this, 3 into dx, nothing wrong in that, plus just you separate 2 to 4. You can write individually, it is 2x dx. I can write like this, no? Because there are two terms, 3 plus 2x. Therefore, integral of 3 into dx I am writing separately, plus integral 2 to 4, 2x into dx separately. That is nothing wrong in that. So, you can write like that. And after that, individually, if you calculate, if you evaluate the integrations, what you will get, this is equal to, for the next step, it is 1 by 18 is definitely, so then it is 3 dx, means that what? Integration, differentiation get cancelled, then x will be there. It is x actually. Then in this, substitute your upper limit and then lower limit, 2 to 4 for this term. Plus, coming to the second term, it is again, 2 is constant here. Take 2 outside. Integral of x. Integral of x is nothing but x square by 2. It is x square by 2. Clear? In this, you substitute limit 2 to 4. 2 to 4. That's it. This implies 1 by 18. Right? So, what is upper limit? You must substitute as upper limit minus lower limit. Clear? So, first you substitute the upper limit minus lower limit. 4 minus 2. That's it. Plus, so it is x square by 2. Means that you can cancel out these two also. You will get only x square. In x place you substitute 4. Means it is 4 square minus 2 square. Upper limit square minus lower limit. That's it. This everything is in bracket. And this implies further, or otherwise I can write here on the left side. So what you will get? So this implies it is 1 by 18 of 4 minus 2. How much? It is 2 plus, what is 4 square? It is 16 minus 2 square. It is 4. This is equal to, it is 1 by 18. How much you will get? 2 plus 16 minus 4. How much actually? How much actually? 16 minus 4. It is 12. Something. It is 14 by 18. It is coming. Is it so? Is it so? 14 by 18. I think we have just 3. I think we have missed 3. I think so. Right? Just one second. I think we have missed this. it is actually, what is that? 3 plus 2x, no, your integral over, it is 2 to 4. 1 by 18 is the constant, definitely clear, and it is 3 plus 2x, 3 plus 2x into dx, clear, and this is equal to what? Actually it is 1 by 18 times, it is 3 into x only, 3 into x plus 2 into x square by 2, if I write overall at a time. Okay, 3x plus x square by 2 basically, is it not? X square by 2, or you can cancel out these two also, and it is 2 to 4 the limits, and this is equal to 1 by 18 times of 3 into what is this actually? 4 minus 2, it is 4 minus 2, upper limit minus lower limit basically, clear? 4 minus 2, it is 2 actually, and then plus x, so it is x square means, so it is 16 minus 4, 16 minus 4, clear? So this implies what you will get here, what you will get, so 3 2s are, it is 1 by 18 of 6 plus how much? 16 minus 4, it is 12, 12 plus 66, it is 18, 18 by 18, that's it, it is 1. I think in previous step we have missed that 1, I think so, so it is 1 now, therefore your integration became 1, therefore you can say the given density function is a valid density function, the given density function is a valid density function, you can write like this, right? This is how we need to solve the problem, right? I think it is quite enough to learn about this density function in today's presentation, and I will finish off this presentation here, and we will continue in our subsequent presentation. Okay, so I thank you all for watching this, and right, we will meet in the next subsequent presentations. Okay, have a nice day.